Okay, in this video we're going to go over some common mistakes when dealing with inferences from conditional statements. Okay, so let's take a look at our conditional statement here. It says that if Obina missed the bus, then he was late for work. Alright, so we've got it diagrammed underneath. Obina missed the bus, followed by an arrow, followed by late. Now the question is there anything else that we can infer? We already know that we can infer the contrapositive, but is there anything else that we can infer? For example, can we just say, if Obina didn't miss the bus, then he wasn't late for work? In this case, we're just negating the conditions. We're not switching them. Well, no. A conditional relationship doesn't tell us anything about what happens when the sufficient condition isn't true. Remember, a sufficient condition is a guarantee. You can not get a guarantee and still get what you want. And it comes up a lot in the test. We refer to it as a false negation. Remember, all the conditional relationship tells us is that if it's true that Obina missed the bus, then it has to be true as well that he was late for work. We don't know anything about what happens if Obina didn't miss the bus. Maybe he caught the bus but there was a traffic jam. Maybe the bus broke down. Maybe he forgot something and he had to go back. The point is that we can't make any inferences if we know that the sufficient condition is false. So remember, when we have a conditional statement, we cannot make an inference where we only cross out both of the conditions, but we don't switch them. Okay, can we make this conditional statement inference? Can we say, if Obina was late for work, then he missed the bus? In this case, we just switched the two conditions. We didn't negate them. Once again, no. A conditional relationship doesn't tell us anything about what happens when the necessary condition is true. A necessary condition is a requirement. So you can meet a requirement and still not get what you want. And this comes up a lot on the test as well, and we refer to it as a false reversal. So remember, all this conditional relationship tells us is that if it's true that Obina missed the bus, then it has to be true as well that he was late for work. We don't know anything about what happens if Obina was late for work. Once again, maybe he caught the bus but there was a traffic jam. Maybe the bus broke down. Maybe he forgot something and had to go back. The point is that we can't make any inferences if we know that the necessary condition is true. And the only inference we can make from this conditional is the contrapositive. That if Obina wasn't late for work, then he didn't miss the bus. If you encounter a situation where the conditions are negated but not switched, then that's not a valid inference from the conditional. And if you encounter a situation where the conditions are switched but not negated, then that's not a valid inference from the conditional either. The only valid inference from the conditional is the contrapositive, where the conditions are both switched and negated. You'll have to watch out for this in the test, since the test makers love to exploit these common mistakes. An argument might have this conditional, and it might also add that Obina didn't miss the bus. And he might ask what has to be true. And one of the answer choices is definitely going to say Obina wasn't late for work. And likewise for the other mistake. So keep that in mind whenever you encounter conditional statements. The only inference you can make is a contrapositive. So, to recap, you can't only negate the conditions and you can't only switch the conditions. A conditional relationship only tells you what has to be true when the sufficient condition is true. It doesn't tell you anything about what happens when the sufficient condition is false or the necessary condition is true.